So the four inequality signs are less than or equal to, greater than, and greater than or equal to. And hopefully through your investigation on your CAS calculator, you've discovered for yourself that open circles are used to represent the less than or the greater than signs, and the closed or the coloured in circles are used to sort of represent the less than or equal to and the greater than and equal to inequality signs. So there's three examples there of the different types of inequalities and how to represent them on different number lines. So in the first example there, you can see the inequality is x is greater than or equal to 0. And so this basically means that this number line that represents that is a number line representing x values. And because we want greater than or equal to 0, we need the coloured in circle, meaning equal to, and we need the arrow pointing to the right, meaning greater than. So the combination of both, greater than 0 and equal to 0. In the second one, you can see that that inequality y is less than 2 would indicate that this number line represents y values, and y less than 2 means y is not equal to 2, but y is everything smaller than 2. So we use the open circle to represent that y doesn't equal 2, and the arrow pointing left, meaning that everything smaller than 2 is included in our answer. And the third type of inequality there on the number line, you can see we've got two endpoints that are represented by circles, and the two circles are joined together with a straight line. So really what that is meaning is that the coloured in circle, or the closed circle, means that -5 is a value that we would want to include in our answer, and all of the numbers in between -5 up to but not including 4 are included. Okay, so not including 4, but yes including -5, and yes including everything in between those two numbers. So mathematically we want to be able to write that somehow nicely. So basically what you need to do first is to write down your two endpoints, which are -5 and 4. And if we're calling this x values, we could call it anything, but if they were x values, we would say that x is in between -5 and 4. So the symbols that go in between will always be at least a less than. They could be a less than or equal to, depending on whether the circles are coloured in or not. So you can see there that the circle on the -5 is coloured in, which would mean we need to put in a less than or equal to on the left-hand part of the statement. And because the 4 is not coloured in, it means it's not included. So we want everything less than 4, but not 4. So we leave that with a less than sign. Okay. The reason they're both less thans, you might be thinking, surely the one on the left is a greater than. The statement, when we're looking at that on the left, if we just looked at the left-hand part of that number line and we had this part, we would write that as x is greater than or equal to -5. So if x is greater than or equal to -5, it means that -5 is less than or equal to x. Okay, and if you think about that, if one thing's bigger than the other, it means the other is smaller than that first original thing. So have a think about that, and you'll see some examples underneath there. Some of them straightforward and simple. The first two in particular, very straightforward, very, very easy. And the last three examples are that type of two endpoints and an in-between. So you will have to read those questions carefully and double check the inequality signs. Are they equal to or just less than in there? And do I need to colour in or leave open? So I'm not going to do those ones. I want you to try those yourself. The next little part of the booklet is solving inequalities. So similar, almost identical to what you already know about solving equations. So if you were solving the equation 3m plus 2 is equal to -4, that's basically a year 7 algebra. You know how to undo two-step equations, and you would subtract 2, I hope, from both sides and cancel, and end up with 3m is equal to negative 6, and then hopefully to get rid of that 3 in front of the m, you would divide both sides by 3 and cancel, and end up with one solution, or one value of m that makes that equation true. If we've got an inequation, it's not going to be one value, it's going to be many values that make that statement true. So we would do the exact same thing as we would if we were solving an equation to start with. So we undo what's happened to m, so we subtract 2 off both sides as always, and we end up with 3m. Rather than 3m equals negative 6, we end up with 3m greater than negative 6. And again, divide by 3, how we have done over on the right, and we end up with an answer of m is greater than negative 2 this time. So m is greater than negative 2 is different from m equals 2, and we know that already because we've done that on many number lines already. So if you were going to express that on a number line, oh, it's m actually, not, oops, it's not x, it's m. So if we were putting that onto our number line represents m values or values of m, and we want greater than negative 2. So we have an open circle because it's not equal to negative 2, and greater than. So any value of m that's greater than negative 2 will make the original statement true. Okay, so it could be negative 1, it could be 0, it could be 6, it could be 500. But anything that's bigger than negative 2 as a value of m, substituted into that original inequation, will make a true statement. Anything less than or equal to negative 2 will not. Okay, so I'm going to leave you with the example 2 to solve for yourself. You'll be able to do that one using the same kind of idea that you would if it was an equation. And the only thing I want to just sort of, I guess, mention, not go into too much depth, but to mention at least, is that the only time issues pop up with solving inequations is when we have a negative coefficient in front of the x. So if I end up with a negative x is greater than 6 or something, and I want to solve for that, that becomes a bit of a problem. So I did want to show you something first before we go back to that example, and just hopefully this will make sense. So if I wrote something like 3 is greater than 2, okay, hopefully you would all say, yes, that's a true statement, and agree with me, 3 is greater than 2. So then if I did something like I've been doing with solving, and I say I might want to multiply by 2 on both sides, okay, and I end up with a new statement that says 6 is greater than 4. Okay, so at the moment, still true. So I'm okay with doing things to both sides of the equation as long as the numbers are positive at this point. So if I had something like, let's say 8 is, I'm trying to pick numbers that are going to be easy to work with, 8 is less than 12, for example. And then I say, all right, I'm going to do something to the same something to both sides, and I might want to divide both sides by 4, say. So if I do that and I say 8 divided by 4 is 2, 12 divided by 4 is 3. The statement's still true. Okay, so it's not a problem to do something to both sides of an inequation until we get two negatives. Okay, so if I start with that same one, 3 is greater than 2 again, let's start here and go 3 is greater than 2. If I did something to both sides of this equation, and I might say let's times by negative 2 on both sides, because with an equation this would not be a problem. Okay, so if I times 3 by negative 2, I end up with negative 6, and I times 2 by negative 2, I end up with negative 4. And if I look at that, my starting statement was true, that 3 is greater than 2, Now I've done something to both sides of this equation, and I've ended up now that this is no longer true. 6 is not bigger than, negative 6 is not bigger than negative 4. If you think about it on the number line, negative 6 is further to the left than negative 4, meaning negative 6 is smaller than negative 4. More negative, smaller. Okay, so this is not true anymore. This is false when I've done this with a negative number on both sides. And so the only way I can fix that and make the statement true again is to actually switch that sign the other way around and say negative 6 is not bigger than negative 4. Negative 6 is actually smaller than negative 4. And then it's true again. So when I've multiplied both sides of that inequality statement there with a negative number, I've ended up with an incorrect statement, a false statement. So the only way I can make that back to a true statement is to switch the inequality sign to the opposite. So let's have a quick look and see if that same thing happens if I do it with a dividing by a negative. So if I started with the, what did I have before? 8 and 12, I think, didn't I? 8 and 12, yep. So 8 was less than 12. True. Now, if this time I divided both sides by a negative, so I might say, let's divide both sides by negative 2 and see what happens. So I'm happy at the moment with 8 is less than 12. And then if I divide both sides, so doing the same thing to both sides of the inequality, we'll see what happens. So 8 divided by negative 2 is going to be negative 4. And 12 divided by negative 2 is going to be negative 6. And we know that negative 4 is not smaller than negative 6. Negative 4 is bigger than negative 6. So it is, again, false. So there's some kind of issue here. Every time I try and do something to both sides of the inequality with a negative, it is wrong. It's the opposite to what I want it to sort of turn out. So the only way I can make this thing back into a true statement is by swapping that sign to the opposite. So negative 4 is in fact bigger than negative 6. Okay, so when we're doing something to both sides of an inequality, as long as it's a positive number, I can do whatever I want basically. I can times by the same, I can divide by the same, and I don't alter whether it's true or false. It's when it comes to dividing or multiplying by a negative number that's the issue, that I need to actually switch the inequality sign. Okay, so you will do a lot of this next year, but I'm just really introducing it here. So this is why when we get up to this last one and we're solving this inequality here, there's no drama until we get to the very last step. Okay, so when you've got an inequation that says 3 lots of 3 minus x is less than 6, my first thought would be, rather than expanding out this bracket, I'm going to divide both sides by 3 to start with, because 6 is divisible by 3, so it makes my numbers a bit nicer. And I end up with 3 minus x less than 2. So I don't really even need my brackets in there. You don't really need to have that bracket in there if you like that without. So I'm going to still try and keep simplifying. And if I subtracted 3 from both sides here, that will disappear and I end up with negative x is less than 2 take away 3, negative 1. Okay, so negative x less than negative 1. So I don't want negative x, I want x. Okay, my number line is not for negative x values, it's for x values. And so what I need to really do is either multiply both sides by negative 1 or divide both sides by negative 1. So this, if this was a normal equation, would be a no-brainer. Let's say we divide both sides by negative 1, and we know what happens when we divide by negatives with these inequalities. The sign's the wrong way around in the answer. So what effectively happens is that the negative goes away in both, and what I need to do to make this inequation work is to swap that sign to the other direction. I know that from my other examples I just tried. So when x is 1, I put an open circle on x is 1, and I want the values that are greater than 1.